Ever get frustrated with how computers just don't seem to get language the way we do?
Yeah.
Today's deep dive is about to change that perception.
Yeah.
We're taking on Attention is All You Need,
Yeah.
a research paper that didn't just tweak machine translation, it flipped the script entirely.
It really did, yeah. It caused a paradigm shift. Before this, imagine teaching a computer a language like it's a slow, painful assembly line.
Oh, wow.
Word by word, completely missing the bigger picture.
Okay, so picture this. I hand you a sentence in Swahili.
Okay.
No dictionaries, no Google Translate, just you and those mysterious symbols. How does your brain even begin to untangle it?
Our brains are incredible at picking up on patterns, even without realizing it. We don't process language in isolation. We innately connect words, phrases, even entire ideas simultaneously get the full meaning.
And that's what makes this research so revolutionary. They said, what if we make AI act a bit more like us? Enter the transformer. Instead of analyzing a sentence piecemeal, it uses attention to grasp the whole thing at once.
It's like the difference between deciphering a code one letter at a time versus seeing the entire message flash before your eyes. The transformer can focus on relationships between words no matter how far apart they are in a sentence.
So no more robotic word-by-word analysis. This thing can actually find meaning in a jumbled mess of words.
Exactly. It's not just about speed, though. It is significantly faster. But it's about how it understands. It's like when you're reading a detective novel and suddenly a clue from chapters ago clicks into place.
Oh, yeah.
The transformer can make those leaps without laboriously rereading every single word.
Okay, that's already blowing my mind, but let's get specific. This whole attention thing, how do they even teach a computer to do that?
It's all about training the model to prioritize. Imagine highlighting a textbook. You're picking out what's important for your understanding. That's what the attention mechanism does, but on a much grander scale.
So it's filtering out the noise to focus on the good stuff.
Precisely. And the paper actually gives a great example, the phrase, making more difficult. Those words are separated, but we understand the connection. The transformer, through self-attention, can grasp that link despite the distance.
So it's like it understands the subtle ways we use language, not just the literal meaning of each word.
Exactly. And then self-attention isn't just a one-trick pony. It actually comes in different flavors. And one of the most fascinating is called multi-head attention.
Okay, multi-head sounds serious. Does the AI get some kind of superpowered upgrade?
You could say that.
Okay.
Think of it like this. You're reading that same detective novel, but this time you've got multiple highlighters. Each color represents a different aspect of the story: characters, plot points, clues. Multi-head attention allows the transformer to do this digitally, analyzing the text from multiple angles simultaneously.
Hold on. So it's not just reading the sentence once, it's dissecting it from multiple perspectives at the same time.
Precisely. It's like having a team of experts, each focused on a different layer of meaning within the text. This multifaceted approach is a huge part of why the transformer is so good at understanding and translating languages.
This is already so much to unpack, and I get the feeling we're just scratching the surface. All right, you've officially piqued my curiosity with this whole multi-head concept. It sounds incredibly complex. How does it even work on a technical level?
Imagine the transformer like a well-oiled machine, with each part playing a crucial role. One of the key components is something called positional encoding.
Okay, positional encoding, it sounds like something out of a sci-fi movie. Break it down for me.
Remember how we talked about the transformer analyzing an entire sentence at once?
Yeah.
Well, that creates a challenge. How does it know the order of the words? After all, dog bites man and man bites dog have very different meanings.
Right, word order is everything.
That's where positional encoding comes in. It's a clever way to give each word a secret code that tells the model where it stands in the sentence. These codes aren't random. They're based on mathematical functions that capture the essence of word order in a way the transformer can understand.
So it's like each word gets a little GPS coordinate within the sentence.
Exactly. This way, even though the transformer is analyzing all the words simultaneously, it still knows that apple comes before pie in the sentence, "I love apple pie."
Such an elegant solution to a complex problem. But we've only talked about understanding language so far. You mentioned earlier that this research went beyond just translation.
Absolutely. The researchers wanted to see if a transformer's incredible ability to understand relationships within text could be applied to other language tasks. So they tested it on something called constituency parsing.
Okay, I have to admit, you've lost me again. What exactly is constituency parsing?
It's like those sentence diagrams you might have done in school. but on steroids. It's the process of breaking down a sentence into its grammatical components, like noun phrases, verb phrases, and so on.
Ah, right, like figuring out who's doing what to whom in the sentence.
Precisely. And what's truly remarkable is that the transformer, even with limited training data for this specific task, managed to outperform previous models.
So it's like it learned the rules of grammar faster than those other models, even with less practice.
Exactly. This really highlights the power and efficiency of self-attention. It allows the transformer to extract patterns and relationships from data much faster than traditional models.
Okay, I'm starting to see why this paper was such a game changer, but I have to ask, if this attention mechanism is so powerful, why wasn't it used before?
It's a good question. Before the transformer, most models relied on something called recurrent neural networks, or RNNs.
Okay.
These RNNs process information sequentially, one word at a time, which made them slow and inefficient for capturing long-range dependencies in text.
So it was like trying to understand a symphony by listening to each instrument play one note at a time.
A perfect analogy. The transformer, with its ability to process everything at once, is like listening to the entire orchestra play in harmony. It's a completely different way of approaching the problem.
This is mind-blowing. So to clarify, the key difference is that RNNs are stuck in the linear world, while the transformer can see the whole picture.
Exactly. And this seemingly small shift in perspective has had enormous consequences for the field of AI. But beyond the technical marvels, there's another aspect of the transformer that I find particularly fascinating. Its inherent elegance.
Elegance. We're talking about lines of code here, not a work of art.
Hear me out. The beauty of the transformer lies in its simplicity. Unlike previous models that were cobbled together with various components, the transformer's architecture is remarkably streamlined. It's essentially just layers upon layers of attention mechanisms and a few other essential components, all working in perfect harmony.
So it's less is more, but in like a brilliant way.
Exactly. And this elegance is not just aesthetically pleasing, it has practical implications. The transformer's streamlined architecture makes it incredibly efficient to train and scale.
And that scalability is what paved the way for the powerful language models we see today, right?
Precisely. Models like ChatGPT, which can generate human-quality text and hold complex conversations, are all built on the foundation laid by the transformer.
It's incredible to think that this one research paper, with its elegant solution to a fundamental problem, has had such a profound impact on the world.
It truly is a testament to the power of innovative thinking and the boundless possibilities of AI. But even with all its achievements, the transformer is not without its limitations.
Oh, I was about to say, it sounds almost too good to be true. What are some of the challenges with this technology? Okay, so the transformer isn't a perfect utopia of AI. What are some of the hurdles?
One of the biggest challenges is, well, context. While the transformer is amazing at understanding relationships within a given text, it doesn't retain memory from one conversation to the next like humans do.
No, it's like reading a book and immediately forgetting everything the moment you close it.
That's one way to put it. This means that for tasks requiring continuous learning or building upon previous knowledge, the transformer, in its original form, has limitations.
That makes sense. And I imagine training a model this sophisticated must require like a ton of data, right?
You're right on the money. Training a transformer effectively requires massive data sets, which can be a significant hurdle, especially for specialized fields where labeled data is scarce.
So there's a risk of the rich getting richer. Those with access to the most data will continue to have an advantage in developing these models.
It's a valid concern, and researchers are actively exploring ways to make transformers more data efficient. But despite these challenges, the impact of attention is all you need is undeniable. It's not just an academic paper, it's the bedrock of a technological revolution.
We've covered a lot of ground in this deep dive. As we wrap up, can you give us the TLDR? Why should our listener care about the transformer?
This paper marks a turning point in how we teach computers to understand the world. Before, it was all about force-feeding information in a linear way. The transformer mirrors our own cognitive processes, revealing that attention is the key to unlocking deeper levels of comprehension.
It's like the difference between teaching someone a language by rote memorization versus immersing them in conversation and letting them pick up on the nuances.
Precisely. And while the transformer was initially designed for language processing, its core principles have implications far beyond that. Imagine applying this kind of parallel processing power to fields like medicine, finance, or even artistic expression.
So attention is all you need is more than just a catchy title. It's a call to rethink how we approach problem solving in the age of AI.
Exactly. It's about embracing a new era of machine learning where computers can finally begin to grasp the world with a depth and subtlety that was once unimaginable.
It certainly leaves you with a sense of wonder about what the future holds. As always, thank you for joining us on this deep dive. We hope this exploration of attention is all you need has left you with new insights and a healthy dose of curiosity for the world of AI. Until next time.
Ever get that feeling like, wow, we're living in the future?
Every day.
Right, our phones are finishing our sentences like before we can even think of the next word. And don't even get me started on the TV. It's like it reads my mind.
It's AI, just everywhere you look, subtly changing how we live.
Exactly. And you know what's wild? It all feels so normal now. We barely even notice it anymore.
Which is why this deep dive is so interesting, at least to me.
Absolutely. Because today we're going back to the source, like the very beginning of a revolution, when computers started to, really get language. And it all started with this research paper.
Attention is all you need. Catchy title, right?
It really is. It kind of grabs you. So, rewind for a second. For those of us who weren't coding AI in diapers, before this whole attention thing came along, how were computers even trying to make sense of language?
Well, imagine reading a sentence, but you can only look at one word at a time.
Okay, that's rough.
And you have to go in order. No skipping ahead, no going back.
Ouch. Yeah, that's basically how computers used to read or process language, I guess.
Yeah, exactly. They relied on this thing called recurrence. And trust me, it wasn't pretty. Long sentences, forget it. Subtlety. Lost in translation, it was clunky, slow. It's like trying to understand a joke, but you only hear one word every 10 seconds.
You'd miss the punchline every time. No wonder our early attempts at talking to computers felt so, robotic.
Yeah.
Okay, so along comes this transformer. Tell me everything.
It's all about attention. That's the key. Instead of looking at words one by one, this model can focus on all the words in a sentence at the same time.
Whoa. So it's like having a bird's eye view of the entire sentence at once, seeing the whole picture, not just the individual pixels.
That's a great way to put it. The model can see how each word relates to all the other words, no matter how far apart they are in the sentence. It's like, have you ever heard of queries, keys, and values?
I can't say that I have.
Okay, so imagine you have a question about a sentence. That's your query. The model uses these keys to find the most relevant information, the values, within that sentence to answer your question. Like a super fast, super smart matching game.
So it's not just about the words themselves, but the connections, those hidden links between them, right?
Mm-hmm.
It's understanding the meaning, the intent behind what's being said.
Yes. And because it can process all of this in parallel, it's exponentially faster than those old models. It's like the paper said, attention is all you need. Figure out those connections, those points of attention, and boom, you've cracked the code.
So it's not just about speed, right? It's like it actually understands the language better.
Yeah.
That's the real game changer here.
You got it. And the results, well, they were pretty mind-blowing at the time. This paper, it dives into all this technical stuff, metrics, but basically the transformer was translating languages way better than anything that came before it.
Give me the numbers. How much better are we talking here?
Okay, so for English to German translation, it beat the previous best model by over 2 BLE points.
2 BLEU points. Is that a lot?
It's huge. Think of it like this. Imagine a phone call, right? All staticky and hard to hear. Suddenly, it's crystal clear. That's what those 2 BLEU points represent. A massive jump in clarity and accuracy.
Wow, no wonder everyone was so excited. And this was just for German, or was it doing this with other languages too?
Oh, it wasn't just German. They tested English to French translation too. Same thing, blew the competition away. And get this, it did all of this in way less time than the other models. Faster, more accurate, more efficient.
This transformer, it's like the overachiever of the AI world. So they figured out translation. Were they satisfied with that, or did they keep pushing it to see what else it could do?
Oh, they kept pushing. This model, it had so much potential. One of the other things they tested it on, this is cool, was English sentence parsing.
Sentence parsing, now we're getting technical. What is that exactly?
It's basically teaching a computer to understand grammar, like how we as humans can look at a sentence and break it down, figure out what's going on.
So the transformer, it wasn't just swapping words between languages. It was actually learning the rules of the language itself.
You got it. And surprise, surprise, it aced that test too. Outperformed almost all the other models on that task as well. They proved this thing was more than just a translation tool. It was a powerful engine for understanding language in a much deeper way.
So this wasn't just a small step forward. This was a giant leap. Like everything changed after the transformer. It's like a before and after moment in AI.
Yeah.
What was the impact? Like what happened next? Did other researchers take notice? I mean, it's huge, right? Going from computers can barely understand a simple sentence to bam, they're practically fluent.
Yeah, it's like that scene in a movie where the scientist walks into the lab and flips a switch and suddenly everything is different.
Total game changer. And I bet not everyone saw it coming.
Yeah.
I mean, you were working in AI back then when this research dropped. Did people immediately realize, whoa, this is it. This is the future?
Oh, absolutely. It sent shockwaves through the entire field. I mean, before this, a lot of people thought, no, you need these complex step-by-step models to make any progress with language. But this paper, it just blew everyone away. Suddenly, the possibilities seemed limitless.
And those possibilities, they kind of took over the world, right? I mean, look at where we are now.
Exactly. All the big AI models you hear about today, like BERT, GPT, these things that power everything from Google search to, those crazy realistic chatbots, they all trace their roots back to the transformer.
It's like this one paper spawned a whole new generation of AI.
It's a legacy that just keeps growing.
Okay, but no technology is perfect, right?
Yeah.
Even with all its superpowers, the transformer must still have some limitations. What are researchers grappling with right now?
One of the big challenges is context. The transformer is amazing at understanding relationships within a sentence, even a paragraph.
Yeah.
But when it comes to longer stretches of text, like a whole article or conversation, it still struggles to keep up.
So it's like trying to understand a movie by only watching a couple of scenes. You might get the gist, but you're missing a lot of the nuance.
Exactly. And that's what researchers are trying to solve. Some of them are working on ways to give these models access to external knowledge, like huge databases of information. Give them more background, more context. Others are developing totally new architectures, new ways of designing these models so they can handle all this extra information without getting overwhelmed.
It's mind-blowing to think that something so essential to our lives now, something we just take for granted, it all started with this one research paper less than a decade ago. Makes you wonder what's next.
That's the exciting part, right? We're just scratching the surface. Who knows what kind of breakthroughs are just around the corner?
Well, that's a great note to end on. We've covered a lot of ground in this deep dive, from those early clunky models to this elegant, powerful transformer. But before we go, I want to leave everyone with something to think about.
Okay, hit us.
If we can teach machines to understand and generate human language, with all its complexity, all its nuance, what does that say about language itself? Is it really something unique to us, something special about being human? Or is it something that can be replicated, even surpassed, by AI?
That's the million-dollar question, isn't it? Gets to the heart of what it means to be human, what it means to think, to communicate.
Definitely something to ponder. And who knows, maybe one of our listeners will be the one to find the answer. Until next time, keep those brains buzzing, and remember, sometimes the most profound discoveries are hiding in plain sight, just waiting for someone to pay attention.
Okay, so get ready, because today we're doing a deep dive on a paper that completely changed how we think about AI and how it understands language. We're talking about Attention is All You Need.
Really a groundbreaking paper.
Yeah, published back in 2017 by some researchers over at Google, and
It introduced this model called the transformer.
right, and it's not an exaggeration to say that it revolutionized AI.
Yeah, it's had a huge impact, and you'll see why as we go through this.
So this is your shortcut to understanding all the cool things AI can do today, like how it's able to understand you and talk back or write different kinds of creative stuff. And we're going to unpack all the key insights from the paper, but don't worry, we're not going to get lost in the
I mean,
weeds.
you can keep it high level. So this paper, it basically solved a bunch of problems that previous language models had. They really struggled with things that we humans take for granted.
Totally. And before we had these things called RNNs or recurrent neural networks.
Right.
And it's kind of like imagine reading a sentence, but you can only process it one word at a time. So you're reading along and you're trying to hold all the previous words in your memory. And then as the sentences get longer and longer, it's like you forget what was at the beginning. It gets really difficult to understand the whole thing.
Exactly. It's like if you're trying to understand a story and you could only focus on one word at a time, and you weren't really able to process it in parallel like our brains do naturally.
It would be impossible.
Yeah, so RNNs had this bottleneck where they just couldn't process information in parallel.
And that's where this paper, Attention is All You Need, comes in, because it introduced this really cool concept, attention.
And this isn't just like a buzzword you hear thrown around.
Yeah, it's actually very important.
It's like if you're reading a mystery novel. You're not paying attention to every single word. Your brain automatically focuses on the important parts, right?
Like the clues.
Exactly. The clues that are going to help you solve the mystery.
It's like our brains are highlighting those key parts to understand the story.
Yeah, and that's what the transformer allows AI to do. Instead of going word by word, it can look at all the words at the same time and then figure out which ones are the most important to focus on.
So it can understand those tricky relationships between words that might be far apart, but are super important for understanding the overall meaning.
Exactly like long-range dependencies.
Okay, so we've talked about attention, but how does it actually work? Like when I saw scaled dot product attention in the paper, I'll be honest, it kind of went over my head.
Well, don't worry, you don't need to be a math whiz to understand it. Basically, imagine you have this sentence and you're shining a light on it. The words that are lit up the brightest are the ones that the model is paying the most attention to.
Okay, that makes sense.
And this scale dot product attention, it's just a fancy way of figuring out how bright each word should be based on how relevant it is to the other words in the sentence.
So it's like the model is creating its own little heat map of the sentence, highlighting the words that are the most important for understanding what's going on.
Exactly.
That's so cool. So it's like the model can see which words are the real power players in the sentence.
Yeah, exactly. And this attention thing is not just some cool trick. It actually makes the transformer way better than those old RNNs we were talking about.
Okay, so like how much better are we talking?
Well, for one, it's way faster. Like the paper says it can be trained in like 12 hours
Wow.
compared to like days for the older models.
That's a huge difference.
Yeah, it's like a total game changer.
Especially when you think about how much data these models have to go through.
Oh yeah, for sure. And it's not even just about the speed. Like the transformer is also just better at understanding language.
So what you're saying is it's like the model is actually learning to understand language, not just mimicking it.
Exactly. It's like it can see the connections between words and ideas in a way that RNNs just couldn't.
So like, give me some examples. What can the transformer do that those other models couldn't?
Well, I mean, think about all the cool AI stuff you see today, like those chatbots that can actually hold a conversation.
Yeah.
Or the language models that can write different kinds of creative stuff. Even those translation apps that are getting scary good.
Right.
A lot of that is built on the transformer.
Wow. So the transformer is like the secret sauce behind all this amazing AI?
Pretty much.
Yeah.
And it's not even limited to language. Like the paper talks about how it could be used for image recognition and stuff too.
Wow. So this one paper, it's like it opened up a whole new world of possibilities for AI.
Yeah, it really did.
Okay, so we've talked about all this cool stuff, but I'm curious, is there like a specific part of the paper that really blew your mind, like something that made you go, whoa, this changes everything?
Let me think.
Give me a favorite aha moment from the paper.
Yeah, so there's this one figure, figure 3, I think, and it shows how the transformer was able to connect the words making and difficult, even though they were super far apart in the sentence.
Wow, so it's like it understood that those two words were related even without them being right next to each other.
Exactly. It's like it figured out the grammar on a deeper level.
It's like it's learning those hidden rules of language that we don't even realize are there.
Yeah, and that was just one example. Imagine what it can do when you scale it up to like billions of words.
It's mind-blowing.
Yeah, it really is.
So we've talked about how this paper, attention is all you need. It wasn't just like a small step forward. It was like a total game changer for AI.
Totally. It changed how we think about AI and language.
And it's amazing to see how it's being used in so many different ways today.
Yeah, it's everywhere.
It's really incredible to think about. So as we wrap up this deep dive, I'm curious, what do you think the future holds for AI now that it has this attention superpower?
That's a great question. I mean, if AI can do all this just by focusing its attention, imagine what else it could learn.
Right. Like what other human-like abilities could it develop?
Exactly. It's an exciting time to be working in this field, that's for sure.
I bet. Well, that's about all the time we have for today's deep dive, but hopefully this got your brain going and you're thinking about all the amazing possibilities of AI.
And if you want to learn more, you can always check out the full paper.
Yeah, we'll have a link to that in the show notes. Until next time, keep those brains buzzing. Ever zone out in a meeting?
Or during like a really long lecture.
Yeah, like when someone's droning on about something and your brain's just like, nope, I'm out of here.
Turns out getting computers to actually like really focus their attention on long streams of information, you know, reports, research papers, that kind of thing.
Right, the stuff that would make even our eyes glaze over.
It's surprisingly tricky, even for those silicon brains.
Which brings us to today's deep dives.
A paper that didn't just shake things up in the world of machine learning, it pretty much did a mic drop.
Attention is all you need.
Bold statement, right.
Definitely not lacking in confidence, but they backed it up.
Oh, absolutely.
I mean, think about all those AI things we just expect to work seamlessly now.
Like instant translation. You talk about a phrase in English, and boom, it's in Japanese.
Or those chatbots that are starting to feel, well, kind of human.
Even those text predictions that seem to know what you're going to type before you do.
It's kind of spooky how good they've gotten.
A lot of that. You can thank the transformer.
So we're talking a major game changer here.
Major.
But before we get all techie, let's set the scene a bit.
Prime the pump.
Exactly. We're diving into the world of, get ready for it, sequence transduction.
Sounds complicated.
It's really not as fancy as it sounds.
Okay, so what are we talking about?
They're basically transforming one sequence of something into another, but keeping the meaning the same.
Ah, okay, I'm starting to get it.
So, like, imagine translating a sentence from English to, say, Mandarin.
You're taking those English words and making them Mandarin words, but the message is still the same.
Exactly. And before our superstar, the transformer, arrived on the scene,
Before it was the cool kid on the block.
we relied heavily on what are called RNNs.
Recurrent neural networks.
You got it.
Okay. Those sound kind of intimidating.
The names can be a bit much, yeah, but the basic idea isn't too crazy.
So break it down for me.
Imagine reading a detective novel, but you're forced to read it.
Ooh, like a choose-your-own-adventure.
Not quite. More like you can only read one word at a time.
Oh, that would be painful.
Right. And then trying to hold all those clues in your head, figure out who did it.
It'd take forever.
Exactly. And that's kind of how RNNs work.
One word at a time.
Yep. Processing information step by step by step.
So not great for long, complicated sentences then.
Or long, complicated anything, really. They get bogged down easily. And if they misunderstand an early word,
It throws everything off.
like a domino effect.
Okay, yeah, I see the limitation there.
And it gets even trickier.
Oh no, what else?
RNNs also struggle with these things called long-range dependencies.
Now you're just using big words to sound smart.
Maybe a little. But seriously, it's a real thing. So picture a sentence like, let's see. The astronaut, famous for her groundbreaking work on space travel, finally published her memoir.
Okay, I'm with you.
Now, for an RNN to figure out that the astronaut is the one who published the memoir.
It has to keep that first part in line while it slogs through the rest of the sentence.
And that can be really, really tough for them.
So it's like they have short-term memory problems.
Exactly. It's like they're constantly saying, wait, who are we talking about again?
I can relate. Happens to me all the time. But okay, so this whole long-range dependency thing.
That's exactly what the authors of Attention is All You Need wanted to fix.
They wanted to create a model that didn't get tripped up by those limitations.
They wanted something that could look at the whole sequence at once.
Instead of going word by word.
And attend to all the parts no matter how far apart they were.
Like having a photographic memory for language?
Now you're getting it. It's all about giving machines the superpower of understanding context, just like we do.
So is this where the transformer makes its grand entrance? More like a grand jeté onto the scene, really? Graceful, but with a serious impact.
Okay, I like that analogy. So how about this when we talk about attention in the context of, artificial intelligence?
Right, not just like pay attention.
Exactly. What's actually going on in the AI's brain?
Think about how we read. We don't just process each word individually, right? It's like
Our brains are making connections between different parts of the sentence, even if they're not right next to each other.
and sometimes we're even like anticipating what's coming next based on what we've already read.
It's like our brains are these prediction machines.
Exactly. And the transformer, in a way, is trying to replicate that.
So it's not just reading the text, it's actively looking for those relationships between words and phrases.
Spot on. It's figuring out which parts of the sequence are most important to understanding the whole thing.
And it does this using, and I'm just going to say it, queries, keys, and values.
Those are the magic words.
I gotta be honest, those words always sound a bit like we're about to unlock some secret code.
Well, in a way we are. It's like this, imagine you've got a giant library,
Okay, I can picture that.
thousands of books, and you're looking for information on, say, the history of artificial intelligence.
Niche. I like it.
So your query is that topic, history of AI.
That's what I'm searching for.
Right. The keys are like the labels on the library shelves, things like computer science, machine learning, algorithms.
They help you narrow down your search.
Exactly. And then the values, those are the actual pages in the books, the information that matches what you're looking for.
So it's like the transformer is doing this whole search process, but for every single word in a sentence.
Simultaneously. Which is mind-blowing when you think about it.
That's a lot of queries, keys, and values.
It really is. But that's how it figures out those attention scores, basically. How much each word should pay attention to every other word.
So instead of reading like a human word by word, it's more like it's scanning the whole thing at once and making connections.
And that, my friend, is where the multi-head part comes in.
Multi-head. Okay, now we're getting really futuristic.
Essentially, the transformer doesn't just use one set of these attention mechanisms. It uses multiple.
Hold on, multiple.
Multiple. It's like having a team of experts, each looking at the same sentence from a different angle.
Okay, that makes sense. One might focus on the grammar, another on the overall meaning, another on the emotional tone.
Exactly. And by combining all those different perspectives,
you get a much richer understanding of the text.
You got it. It's called multi-head attention. And it's one of the things that makes the transformers so powerful.
Okay, I'm starting to see why this thing was such a big deal. But I have to ask if we're ditching that whole step-by-step processing thing.
Right. No more marching through the sentence one word at a time.
How does the transformer keep track of word order? I mean, dog bites man is a very different story from man bites dog.
Ah, this is where things get really clever. Remember how we were talking about those positional encodings?
The things that tell the model where each word belongs in the sequence.
Precisely. It's like giving each word a little number tag. So even though the transformer is processing everything at once, it still knows the order.
So it's like, hey, I know I'm analyzing all of you at the same time, but I haven't forgotten that you came first, you came second, and so on.
Exactly. And they found that using these wave-like mathematical functions, sine and cosine.
Wait, like from trigonometry?
You got it. They work surprisingly well for creating these positional encodings. Each position in the sentence gets its own unique pattern.
So the transformer learns to recognize those patterns.
And that's how it keeps track of word order.
It's like encoding the very concept of sequence into the math itself. That's pretty wild. But all this talk about architecture and mechanisms is great.
Don't you love a good deep dive into the technical stuff?
Of course, but at the end of the day, it all comes down to, did it actually work? Did the transformer deliver?
Oh, it delivered in a big way. Especially when they tested it on, that classic machine learning task translation.
English to German. Right.
That's the one. The transformer just blew everything else out of the water.
Didn't they say it beat the previous best models by, like, a significant margin?
More than 2 points on the BLEU scale?
BLEU scale. Okay, gotta admit, that one's going over my head a bit.
Right, sorry. BLEU, it stands for Bilingual Evaluation Understudy. It's just a way to measure how good a machine translation is.
So, like, how close it is to what a human would actually say.
Exactly. The higher the BLEU score, the better the translation. And the transformer. It got a record-breaking 28.4.
So, significantly better than anything we'd seen before.
It was a huge leap. But here's the thing. It wasn't just more accurate. It was also way faster.
Hold on. We're talking about speed, too. I thought we already covered that whole thing about how it's processing everything at once.
Right. So because it's not stuck going word by word, like those RNNs we talked about, it can be trained much faster.
Even on those massive data sets that would make other models just, like, crash and burn.
Exactly. Less waiting around, better results.
Yeah.
It's a win-win.
Now that's what I call progress. Okay, so we've talked about translation, but the paper also mentioned something about constituency parsing.
Yes. Constituency parsing.
Which sounds way more complicated.
It's basically about understanding the structure of a sentence, like breaking it down into its grammatical parts.
So figuring out the noun phrases, the verb phrases, all those building blocks of language.
Exactly. It's like taking a sentence and creating a map of how it all fits together grammatically.
And the transformer could do that too.
And it did it incredibly well. Achieved state-of-the-art results there too.
Okay, so it's a master of language, it's got speed, it's efficient. Is there anything this transformer can't do? Should we be scared? Is this the beginning of Skynet?
Let's not get ahead of ourselves. It's still just a tool. But you're right, the potential here is massive. And the authors of the paper, they saw that right away.
They weren't just focused on language, were they?
Not at all. They were already talking about how this architecture could be applied to images, audio, video. They basically opened up this whole new world of possibilities.
And it's amazing to think that so much of what we see in AI today, From those scarily realistic images to chatbots that can hold a conversation, it all goes back to this one paper.
This one idea, attention is all you need. It really goes to show how quickly this field can move.
And how one elegant idea can unlock so much.
And it makes you wonder what other breakthroughs are just around the corner. What other simple but profound ideas are waiting to be discovered?
It's exciting, isn't it? The possibilities are pretty much endless.
Absolutely. Yeah, who knows? Maybe this deep dive will spark some new ideas for our listeners too.
Well, that's all the time we have for today's deep dive into the world of the Transformer. But for those who want to go even deeper,
And trust me, there's a lot more to explore here.
the full paper, Attention is All You Need, is definitely worth the read.
It's a classic for a reason.
It might just change the way you think about artificial intelligence, and maybe even about how your own brain works. Until next time, keep those minds curious, and remember, sometimes the greatest discoveries come from simply paying attention.
All right, everyone, get ready, because today we are diving into a paper that's really like the bedrock of modern AI.
Mm-hmm.
We're talking Attention is All You Need,
Yes.
the birthplace of the Transformer model,
Right.
which you've probably heard of. It's making waves,
Yeah.
really, in the world of AI.
It's huge.
But, we're not just going to skim the surface today. We're going deep,
Yeah.
really trying to get to that aha moment of why this paper is such a big deal,
Absolutely.
why it's considered, groundbreaking. By the end of this deep dive,
Yeah,
you're going to really understand, hopefully, like what makes this AI tick,
I'm excited.
the core concepts,
It's going to be good. Well, for me, it's an exciting journey, and I'm happy to guide everyone through it, as always. My background working in AI and natural language processing, I've had like a front row seat to really the impact of this paper.
Oh, absolutely.
And trust me, it's been transformative, pun intended.
Yeah.
The Transformer.
Okay, so before we get to all the groundbreaking stuff,
Okay,
let's rewind a bit.
let's do it.
Before this paper came along,
Mm-hmm.
what was the AI landscape like?
Mhm.
What were some of the challenges that this model was trying to address?
Okay.
I think I have a good analogy to kind of illustrate this.
Okay, yeah.
So imagine you're trying to read a book,
Okay.
but you can only read it one word at a time.
Oh, wow.
And you're trying to hold the entire plot in your head as you go.
Right.
Be incredibly slow and probably super frustrating.
Absolutely.
And that's kind of what these traditional recurrent neural networks, or RNNs, had to deal with.
Yeah. I mean, that's a great way to put it. They process information sequentially.
Right.
So if you imagine, like you said, going through a sentence word by word,
Word by word.
it's meticulous and it has some drawbacks. Like first, it's super slow, difficult to parallelize those computations.
Right, it's like a bottleneck.
Exactly. But I think more importantly, the sequential processing, it makes it hard to learn these long-range dependencies in language.
Right.
Where a word at the beginning of a sentence might actually be related to another word much later on. And you need that, like, to really understand a text.
It's like those readers that highlight every single word, hoping something will stick, but they
Yeah.
miss all the connections.
Yes, 100%. And that's, I think, where Attention is All You Need really shines.
Okay.
Because it introduces this idea of self-attention.
Okay, yeah.
So instead of that word by word, you can jump between any two sentences.
Wow.
Instantly grasp their connection.
Okay.
That's the power.
So instead of reading linearly like a robot almost, self-attention lets the model see the entire text and make those connections. Across sentences even.
Exactly. It can look at all the words simultaneously, calculate how relevant they are to each other,
Okay.
and because it can do that all in parallel much faster.
Got it.
But it's not just about speed.
So it's not just speed reading, it's understanding it on like a deeper level.
Yeah, because it analyzes everything together.
Ah.
It can pick up on those long-range dependencies that tripped up the RNNs.
Oh, right.
It's like, it just knows. You know what I mean?
It's like it develops a sense of the grammar and the context.
Yes, exactly. Like an intuitive sense of it.
And they actually show this in the paper with an example, right?
Yeah, I do.
Something about the word making.
Yes. Figure 3, it highlights it. So let's say your sentence is, new laws since 2009 making the registration or voting process more difficult.
Okay.
If you're focused on the word making,
Yeah.
self-attention lets the model instantly know that's connected to more difficult, even though there's a bunch of words in between.
So it understands that making is what's impacting more difficult.
Yeah,
Wow. Okay.
powerful stuff.
That's really cool.
Yeah.
Okay, that's really cool. But how does self-attention actually Like, how does it work?
Yeah.
It still sounds a little bit like magic to me.
I get that, but it's actually, when you break it down, pretty intuitive.
Right.
Imagine you're searching for something online.
Okay.
You type in a query, so the thing you're looking for,
Right.
and then the search engine is going to match it with relevant keys, which are like tags attached to web pages.
Right.
And then it shows you the results, which are the values.
Okay, so like if I'm searching for like more about the transformer model, I would type in like transformer model AI. Those are my queries.
Exactly. And then let's say the search engine has indexed a bunch of web pages with those keywords. Those are the keys.
Right.
And then the values are the actual content of those pages, ranked by how relevant they are.
Okay, got it, got it. So self-attention is like the ultimate search engine for language then.
That's a good way to put it, yeah. So in self-attention, each word in a sentence becomes a query, a key, and a value.
Okay.
So going back to your example, the cat sat on the mat. The word cat would have a query, like representing its role.
Okay.
Like, I am a noun,
Okay.
maybe the subject of the sentence.
Got it.
And then the keys would be things like animal, feline,
Okay.
and then the value is the kind of the meaning in the specific sentence.
Oh, that's really cool. Okay, so then the attention mechanism takes all these queries, keys, values, and is figuring out like which words are most relevant to each other.
Exactly. Yeah, it calculates like a compatibility score,
Okay.
between the query and all the other keys. And then that creates a set of weights that determines how much each word should pay attention to the other words.
Okay.
So you can think of it like a spotlight.
Okay.
Each word is shining a spotlight on the others.
Gotcha.
But some are brighter based on how related they are.
That's a cool visual. So words that are like closely related, like cat and sat,
Yeah.
would have like a stronger connection, a brighter spotlight.
Exactly. And so this is really how it picks up those subtle relationships.
Yeah.
Understands the context, even if those words are far apart.
Wow. Okay. Yeah, no, this is starting to click now. This is really cool. But, the paper also mentions multi-head attention. Is it like having multiple search engines running at once?
It's another good analogy. Yeah, so it's like having multiple experts all reading the same book,
Okay.
but each one is focusing on different aspects.
Gotcha.
So one might be focused on the plot, another one on character development, another one on like writing style.
Got it.
And so together, they all give you a much richer understanding of the whole story.
So it's not just about finding any connection between words, but like all the different ways they could be connected.
Exactly. Multi-head attention uses several attention heads that all work in parallel.
Right.
But each head focuses on different aspects of that input.
Gotcha. Got it.
So, yeah, they capture a wider range of those relationships.
So like one might be focusing on how words modify each other, and then another one is focused on like subject-verb agreement.
Yeah, you got it.
Okay.
And figures 4 and 5 in the paper, they show this really well.
Oh, cool.
How different heads are picking up on things like anaphora, which is where a word refers back to something earlier, or even like the grammatical structure.
Wow. Okay.
Pretty cool.
So each head is like a specialized linguist.
Yeah.
And then together, they're giving this multifaceted understanding of the language.
Yeah.
That's incredible. Okay, so this multi-headed approach, it's really what makes a transformer so special.
Yeah, it's amazing.
But it's not just about, translating languages anymore. This goes way beyond.
Oh,
right?
absolutely. It's had such a huge impact.
Yeah.
And actually, the paper itself talks about another interesting application.
Okay.
English constituency parsing.
Okay, now for those of us who don't speak AI jargon,
Sure.
what exactly is that?
Yeah.
Sounds pretty intense.
It's not as bad as it sounds.
Okay.
It's basically, you're figuring out the grammatical structure of a sentence.
Okay.
So like identifying the subject, the verb, the object, all those pieces.
So it's kind of like we used to diagram sentences, right?
Yes.
Back in the day.
Yeah.
It's like it's doing that for us, but like in this really advanced way.
A much more advanced way, yeah.
And they were able to do this without even changing the model, really.
Yeah, that's what's interesting. They applied it without any big modifications.
Wow.
And it still worked well.
So what does that tell us then?
Yeah.
Like, why is that so significant?
Well, I think it shows that, constituency parsing,
Right.
it has its own challenges, right? Like the output is structured,
Yeah.
it has to follow rules, and it's usually much longer than the input.
Okay.
But the fact that this worked, it kind of suggests that it's not just learning patterns, It's something deeper about the structure of language itself.
So it's like it's cracked the code in a way.
In a way. Yeah, I like that.
Like, it's not just understanding the words, it's understanding, like, the grammar, the syntax
Exactly.
behind it. Wow. And that's why this paper's such a big deal.
Yeah, for sure.
Because it showed that self-attention, this idea.
Right.
It wasn't just a cool trick for translation. It was like this fundamentally new way for AI to understand language.
Exactly, on a much deeper level.
It's really incredible when you think about it, that this idea that's really inspired by how we search for information online.
It's so true, yeah.
Is now powering these super advanced AI systems. And it's doing things we couldn't even imagine just a few years ago.
That's the thing about AI, it's ever evolving. Like this paper, it was the spark.
Yeah, the starting point.
And researchers are like running with it, pushing the boundaries of what's possible.
Yeah, and you know, with these AI systems becoming more sophisticated, like understanding language on this whole other level, who knows what the future holds?
Right. It's exciting.
It is exciting.
And a little mysterious.
And a little bit daunting. Like, I don't know, it's both.
All right. For sure. For sure. So for everyone listening, you know, as we're entering this new age of AI, where machines are becoming so fluent in our language, in a way, how do you think our relationship with technology is going to change?
Right.
What new doors are going to open, and what new questions should we be asking ourselves?
That's something to think about. Keep those questions in mind, and until next time, happy exploring.